Okay, so today we're going to be doing distillation. We're going to be separating a mixture of ethyl acetate and acetone. We're going to be using two methods. One is a simple distillation and one is fractional. The difference between simple and fractional is this column of glass beads. The glass beads are there to essentially make it harder for the solvent with the higher boiling point to travel up, meaning you get better separation, essentially is the idea. Okay, and so you'll be working in teams so you can compare the simple versus fractional methods. What we'll be doing is we'll set up these distillations depending on which one you choose, um, where you have a thermometer, a Y adapter, round bottom flask, a condenser, and a vacuum adapter, whereas the fractional is the same, but you'll have a glass bead column as well. What you'll be doing is you'll be collecting, um, you'll monitor like the volume of solvent coming out and be writing down the temperature that your thermometer is showing. So like every milliliter you should write down what temperature it is. After 5 milliliters are collected, you'll switch a graduated cylinder to a vial, collect some, like about 5 drops of the solution at that point, switch it back to your graduated cylinder, collect it till 15, and then collect the solution again for both of these. What you're going to be doing with those solutions, or with that data, is one, you're going to be creating a temperature versus volume graph, similar to what's shown in the lab manual. Then you'll also be collecting NMR and GC of these mixtures to determine what the ratio of ethyl acetate to acetone is at the different points of your distillation. Okay, so we have both the distillation setups going. So this is the fractional distillation where we have the column inserted. A couple of key things to remember when you're working with this type of glassware is you want to make sure all your joints have grease on them. Otherwise, your solvent's going to escape through them and they can actually get fused together. What you're looking for when you grease it is for it to become clear. You also want to make sure you have kept clamps or the yellow clamps on there to secure the joints as well. And then you want to have it secured by the clamps on the ring stand as well. So they're both very stable. When you have your water running, you want to also make sure the head space is filled with water so you can get the maximum coolant effect so that it turns from vapor back to the solvent as you're distilling. And we also have our graduated cylinders set up so we can collect the distilled solvent as we run it. And then you also want to have a couple vials ready to go for your 5 milliliter mark and your 10 or your 15 milliliter mark. Okay, so we're ready to start. We'll set it to 5 and start heating. So first, when we're running GC, we want to make sure the needle is clean, so we'll just fill it up with our sample and inject it into a chem wipe a couple times just to make sure it's just our sample we're measuring. We'll fill it up to about 0.2 to start with. It's such a small volume that you won't see anything really. Okay. Now we're going to pull up 0.2 microliters. So we have our liquid in our needle. We're going to inject this part of the needle up to the stopper here into our GC. So you just go down here to the port, carefully stick it in, stop when the stopper hits. I'm going to hit collect and inject at the same time. Okay, so now we have our data from our 5 milliliter fractional distillation sample. So to get the peak integration or the relative amounts of each compound, we're going to go under Analyze, Peak Integration, and then just drag our cursor to collect the peaks. So that's the first peak, go Add, second peak, and go Add. Okay. And then under here, it tells you the relative percentage of each area. So this is saying peak 1 is going to have 93% and peak 2 is about 7%.